All right. All right, so last time's notes, remember we were doing all the areas by hand, blah, blah, blah. Okay, then on the back side of that, you had some questions that we didn't get to. Ugh, this thing. Okay, that go with the last half of your homework. So if you'll look at that very top question, you'll notice that you have three integrals. You have an integral 6 to 9. Do you see it? And what is it equal to? -2. Then you have another integral that's from 2 to 9. And then they're asking you to find the integral from 6 to 2. So we are going to use the property, if this will work. There we go. Okay, right here. You don't have to flip back. But on the page before, we talked about that if you want to integrate from A to B and then B to C, that's the same as if you just went straight from A to C. Do you remember talking about that? Okay, so now go to the question that you're on. The longest interval that I see is from 2 to 9. So I'm going to write down that the interval 2 to 9 f of x is equal to the integral from 2 to 6 plus the integral from 6 to 9. Okay, now I just want you to look at that and see if that makes sense as a strategy. That if I want to go straight from 2 to 9, that would be equal to if I went from 2 to 6, then I stopped, but then I picked back up at that same 6 and kept going till 9. Are we all good with that? Mm-hmm. Okay, so now they tell me that 6 to 9 is -2. So I'm going to put a -2 in this spot. And then they tell me that from 2 to 9, my answer is supposed to be -7. So then the only integral out of 3 that I'm missing is the area from 2 to 6. And so what I want you to do is just think about that as if it were an equation. If I had -7 equals a minus 2, how would I solve that? Just add the 2 across, what would a need to be? So +2, I can't fit it in there, but +2 on both sides, your a is going to be -5. Now, quick question. That's the area from 2 to 6 that we were missing. Is that the integral that they're asking me for? They're asking me from 6 to 2. Do you remember what you do if the numbers are in the wrong order? Switch the sign. So the actual area is -5, but because this guy is backwards, it's going to equal +5. Okay? All right, that might be a little confusing. Let's try another one. Take a look at number 2. I have an integral from 9 to -2, 9 to 10, and then -2 to 10. Which of those is the longest? -2 to 10. So I'm going to do integral -2 to 10 equals. And then what is my number that I'm going to make the little pit stop at between -2 and 10? 9. I'm going to go -2 to 9. And then I'm going to add 9 to 10 to that. Okay, and based on the properties we did last time, this should make sense. That if I go -2, make a pit stop at 9, pick back up at 9, go to 10, that's the same as this. Now let's plug in our numbers. 9 to -2 is -6. Then what will -2 to 9 be? This is a +6. And then 9 to 10 is how much? It gives me the value right here. 9 to 10 is equal to 5. So then the missing area that I want is equal to 6 plus 5, which is 11. Now, go back to your question. Make sure, do they want the integral in the correct order from -2 to 10? Is that what they're asking us for? Yes, then 11 is going to be the correct answer. I don't have to like change the sign or anything like that. Okay. Next one. What is the longest of the 3 intervals that you see in question 3? We have a -9 to 7, -7, -9, and a -7 to 7. Which one's the longest? Okay, now I'm going to show you, a lot of times I'll have kids that like this better because it's a little more visual. But I want you to do a number line from -9 till 7. And then where are we going to make our pit stop at? What number between those? -7, great. Okay, then from -9 all the way to 7, I know the value should be 5. But from -7 to -9, that'd be this piece. I know that it's a -2. Now, can you fact check me on that? Are these the same? This one's what? Backwards, it's flipped, which means that if -7 to -9 is -2, what would -9 to -7 be in the correct order? +2, correct. And then you would say, okay, well then what does this piece have to be for this plus this to give me 5? Does that make sense? Mm-hmm. So what would it have to be? 3. So my missing area in this case would be 3. Now, that's the integral from -7 to 7. Is that what they're asking me for here? Almost. What number did they sneak in there? A third. So then if I do a third of 3, that means my final answer here would be 1. Okay. Now, if you like this representation better or the straight line better, I don't care. Either one will work, but I'm going to do the line because it's kind of less writing. So let's take a look at number 4. My longest interval, -9, 5, -9, -1, -1, 5. Which one's the longest? -9 to 5. And then where are we going to make a pit stop at between those? What number? -1. Very good. From -9 to 5, what is my area equal to? -2, and it is already in the correct order. So I know that this piece plus this piece should give me -2. My -1 to -9 is 8. So I'm going to place that here. Can we fact check? Is 8 the correct value for that? No, because what's wrong with the order here? Backwards. -9 is the smaller of those two numbers, then it should be on the bottom. So this is actually a -8. And then you would say, okay, well, if this is a -8, what would have to go here so that when I add these two pieces, I get -2 plus 6. Very good. Okay, so my area equals 6. Okay, now look at your integral. You're going to notice that in this case, we have the integral from -1 to 5. That's in the right order. But our f of x has a +3 with it. So this is new. We didn't cover this last time. But if you have an integral, f of x +3, you can split that into an integral -1 to 5 of f, and then -1 to 5 of 3. So notice that if it's a multiplier in there, you can just find the area and times it. Okay, but if it's a plus, you're going to separate them each into their own integral. And now we know the answer to this. What's the answer to this part? For f, it's going to be 6, right? But for this one, we're going to have to sketch a graph. So this answer I already have. I found out that it's 6. Okay, but the question is, what do I do with this 3? So I want you to sketch a graph of y equals 3. We covered this last time. So I should be at a height of 1, 2, 3, flat line across. And then I'm going to shade along the x-axis, starting at what number? And stopping at 5. So from -1 to 5, remember, I'm going to shade the x-axis first, and then I'm going to shade up to the function because I want to stay in between. And then remember, I would calculate the area of that. So if this is a -1 and this is a 5, what is the length of my base here? 6 units. How tall is it? 3. So if it's a 6 times 3 box, how big is that? 18. And then 6 plus 18 gives me a final answer of 24. So if this is a function, you would just graph it. 3 by itself is a nice, easy, flat line, which gives us a rectangular area. Okay, let's try one more like that. Take a look at number 5. Set up your number line. I'm seeing numbers 0, 10, 10, and -9. So I want the longest interval to be my endpoints, which would be what 2 numbers? -9 far left, 10 far right. And then our stopping point in the middle is what value? 0. From 0 to 10, what is that length going to give me? 0 to 10 gives me 7. And then -9 to 10, that'd be all the way from here to here, gives me -3. So then I just need to think about what's missing here, that when I add it with 7, the answer will come out to be a -3. What would it need to be? -10. Very good. Okay, because -10 and 7, that adds up to give me my -3 across the bottom. Okay, now look at your integral. I want the integral from 0 to -9 of f of x plus 2. But because this is addition, I'm going to give everybody their own integral. So I'm going to integrate the 0 to -9 on f first. And then I'm going to add the integral 0 to -9 on 2. This answer, though, I already have. How much area is there on this interval? What was the missing area? -10. Will I use -10 as my answer? Look at your endpoints. You see how it's backwards? So instead, I'm going to use what number? +10 plus. And then for this part, I'm going to have to construct a graph. So if you graph the function y equals 2, okay, so we'll do sketch y equals 2. So that's right there. And then we're only going to shade from 0 to -9 along the x-axis. That would actually be this way. And then you would kind of shade in between. And you'll notice you're making a nice, easy rectangle. How tall is the rectangle? How many units? 2. How wide is it if it's from 0 to -9? 9 units. What's 2 times 9? 18. Will I count the value as 18? Look at your endpoints. It's backwards. That means it's going to be a -8. So watch out that if they're backwards, my area is 18, but that integral, oops, I almost said backyard. Backwards. Okay. So because it's backwards, that's why I'm giving it a -18, and then 10 and -18 give you -8. Does that make sense? Okay, you'll have tons of time to practice that on last time's homework, but we're going to just add a little bit to our what we learned last time and some calculator stuff, and then your homework today is only like 4 questions. Okay, so you'll have a lot of time to go back and work on last time if you need it. Okay, so take a look at today's. Last time we learned that when you're doing an integral, do you remember you're finding area? Area above counts as positive, below counts as negative. So can you calculate the integral on this graph from 0 to 4? So where would I start shading? What number? 0, and I'd stop at 4. And then remember, I want to shade between the x-axis and the graph I'm given. That would be shading right here. What shape is that? Triangle. 1/2 base times height for triangles. What is my base this time? Careful, make sure you look at each box is worth 2. So it'd be 4, and then my height is 2. So it'd be 1/2 4 times 2. Overall value, what is it? 4, what will the value of this integral be? Where's the area? Below, so it needs to be -4. Okay, because I accumulated area below the x-axis. Okay, second part we want is the integral from 4 to 10. So I would look at my x-axis, 4 to 10, shade it. And then shade up to the graph. What shape are you shading? Okay, very good. Trapezoid is correct. Remember that the area formula for a trapezoid is going to be 1/2 base plus base times height. Remember, your bases have to run parallel to each other. So that means that this is a base here, and then this is a base here. And then your height would be along here. So how long is the top base? 2. How long is the bottom base from 4 to 10? 6. And then my height I see here is 2. 2 plus 6 in the middle is 8. And then the half and the 2 just kind of cross each other out. So it's going to stay in 8. Okay, then for the last one, I want to integrate all the way from 0 to 10. What will I do with these two values? Add them or subtract them? Subtract. That your 4 counts as a minus, but your 8 counts as a plus. So -4 plus 8, my overall value would be 4. Okay, specifically if you're doing this on a velocity graph. So notice, this is a velocity graph. Okay, when you calculate the integral on a velocity graph, you're going to get the directional change in position. Okay, that's going to be measured. If this is meters per second, it would be measured in meters. And then it would be over the interval from A to B seconds. Okay, however, the amount that your position changes already has a name. It's called, what is it called? Displacement. Okay, displacement. And so if you want to think about what displacement is, that is your net change in position from start to finish. So for example, let's pretend that our squirrel is at 1 and it runs over to position 5. What would its displacement be? From 1 to 5, it moved 4 units to the right. Now, let's say the same squirrel starts at 1, but it ends at -4. What would its displacement be? -5, because it ran 5 units which way? To the left. Does that make sense? So it's the directional or net change in position. Okay? Now, if you want to know exactly how far the squirrel ran, that would be called total distance traveled. Okay, and that would be the integral of the absolute value of velocity. Okay, and let me take one more stab at explaining this. I'm standing right here. I walk to the door, and then I walk right back to the same spot. What's my displacement? 0, because I started and ended in the exact same position. Okay, but my distance traveled, let's say it's 10 yards to the door, then if I went 10 yards there and 10 yards back, what's my distance traveled? 20. We see the difference? So displacement, if you start and stop at the same spot, you didn't move anywhere, right? But really, you know, you did. So that would be kind of the difference, okay? So now let's do it for our squirrel. So if I want displacement, I'm going to integrate velocity from 0 to 10 seconds, and that's going to give me +4. Because the squirrel traveled to the left 4, and then to the right 8, and so its ending position is 4 units past, or we'll say on right of the starting position. So let me give you a second to write that down. So if the displacement is 4, the ending position is 4 units past whatever the starting position. Versus distance traveled would be the integral from 0 to 10 of the absolute value of velocity. And when you put absolute value bars, you're saying, I don't care which way you went. I want to know every step that you took, and I want to add them all together. So if the squirrel went backwards 4 and then forward 8, how many did he go? 4 plus 8 would give you 12. Correct. So he traveled a total of 12 meters. And it doesn't matter that 4 of them were backwards and forward that canceled out with each other. Okay. So this is the total distance traveled. Over the 0 to 10 seconds. Okay, but you only have to worry about this application is if it's a velocity question. So when you're ready, go ahead and turn the page. We're going to put it all together on a velocity graph. One without the calculator, one with the calculator and number. Do we need this up here longer? Okay. All right, next page. You have a velocity graph. We have a bug that is crawling on a wire. Okay, this is velocity. How do I know when the bug is traveling to the left? This is all stuff you already know. This should be old. When it's negative, which means below the x-axis. Where is that? Okay, 6 to 8. And then I'm going to put because b of t less than 0. Because we know that if my velocity is negative, that means my particle or my bug in this case is traveling to the left. Where would the bug be traveling to the right? 0 to 6. Because velocity is greater than 0. So remember, positive velocity traveling to the right, negative velocity traveling to the left. Next question, when does the bug change directions? Where would that be? At 6. And remember, whenever the bug changes direction, that's where your velocity is equal to 0, and it has to pass through the x-axis. Okay, it has to actually switch either from the positives to the negatives or from the negatives to the positives. Okay, then it says, is this point a relative max or min for position? Well, look at your point at 6. How does the sign change at 6? Before 6, it's positive. After 6, it's negative. Then is that consistent with a max or a min? Max is right. And then think about it. It's a positive slope, then a negative slope. That's a max. So we'll put this is a relative max because b of t changes from the positives to the negatives. Okay, next question. I want the bug's acceleration. This is a velocity graph. What feature is acceleration on a velocity graph? Slope. Very good. So I want you to put right here, acceleration is the slope of a velocity graph. And remember, the only way that I can ask you to give me the slope is if it's a straight line that you can count the rise over run. So first we're going to find the acceleration at 1. Then we'll find it at 3. Then we'll find it at 4. Okay, let's start with 1. Go to your graph, find 1, and tell me, is it already a pretty point? If I go to 1, am I on a pretty point? No. Then use the endpoints and count the rise over run. So I'm going to draw my line segment in here, and then I'm going to do rise over run. Okay, but remember, you want to try to use pretty points meaning they're exactly on an intersection. So if I go from here to here, what's my rise? What's my run? Then my acceleration is 3/2. Okay, next find 3 seconds on your graph. Okay, 3 seconds on the graph would put me right here. And when I look at that line segment, I can tell you the slope without counting anything. If it's perfectly flat like that, what's that slope? 0. Okay, I'm going to put, because it's horizontal. And we know that a 0 slope and horizontal are the same thing. Okay, next question. I want the acceleration at 4. Find 4 on your graph. And you'll notice that 4 is perfectly on a corner. Can you calculate the slope at a corner? No. So the word for that is that at 4, it is not differentiable. Okay, and the reason it's not differentiable is because on a corner, okay, you have different slopes on either side. That I have a flat slope if you look at your graph on the left of 4, but then I have a downhill slope on the other side that you don't know which slope to take. Okay, so on a corner, you can't take the slope, which means we can't calculate acceleration. Okay, this is the new stuff. I want the displacement of the bug at 8 seconds. Then I'm going to integrate velocity from 0 to 8. And remember that an integral means we're calculating area. So go up to your graph, shade the x-axis from 0 to 8, and then shade the space between the axis and the graph to find your shapes. So 0 to 8 would be here to here. How many areas am I going to have to find? 2. You have a big trapezoid on top, and then you have a little bitty triangle on bottom. Let's do the trapezoid first. It's going to be 1/2 base plus base times height. How long is the top base? 2 boxes. How long is the bottom base? 6. And then what's the height between them? 2 plus 6 is 8. Cut it in half is 4 times 3 is 12. So here's what we know. Over these 6 seconds, not only do we know that the bug traveled to the right, we know how far it went. It went 12 units to the right. Okay, now my triangle on the bottom represents the bug going backwards. If I want to know how much, I'm going to calculate the area. So I'm going to do 1/2. How long is my base? 2 times my height is 1. Okay, the half and the 2 are going to cross out. You'll just basically have 1 unit. So the bug went forward 12, but then negative or backwards 1. What would my overall displacement be? 11 is correct. So put 12 plus -1 is 11. And that means that the bug ended 11 points above wherever its starting point is. Okay, we're going to come back to D, but go down to E. Let's say that I know where the bug started. Read right here. It says, suppose the bug begins 3 inches above the bottom of the wire. Find the position of the bug at 8 seconds. Okay, your final position, I want you to write this down, is going to equal your starting position plus your displacement. So here's what that means. If I know the bug's starting position is 3, and I know that its net change in position is 11, where is its final position going to be? Already at 3, and then it goes overall up 11. Where would it be? 14. Very good. So we're going to put the position at 8 is the starting position 3 plus the displacement, which is 11, for an overall position of 14. Now, if you want the distance traveled by the bug, then remember every area counts as positive. So if I want the distance traveled, I'm going to still integrate 0 to 8, but I'm going to absolute value bars around my velocity. And what would my distance traveled be? 13, because it'd be 12 plus 1, which is 13. So essentially, for distance, you're not letting the pluses and the minuses cancel each other out. You're counting everything as positive. Make sense? Okay. Let's go ahead and do a little chart for F. Make me a little position chart here. At 0, what did they tell me the position was? They gave it to us here. Yeah, it was 3, right? Okay, by 6 seconds, your bug had accumulated the whole trapezoid, which was how much area? 12. So it went forward 12. Then at 6 seconds, where was the bug? 15. Very good. And then by the last 2 seconds, that puts me at 8. The bug went how far backwards? Think about the area. It went backwards 1. That puts it at 14, which is the exact same answer we got here. So if you like it better in a chart form, that's totally fine. Okay, but you do need to know that general kind of concept right there. Okay, so then what would my max position be now that we're looking at our chart? 15, what would my min position be? 3. So we'll say the max position is 15. The min position. All right. So now we're going to do the same thing, but you're going to learn some more calculator stuff. So the first thing that I need you to do is reset your memory to be in radian mode. Okay, otherwise your answers are going to come out wrong. And my pre-cal kids just all switched them to degrees for their test. So you're going to do second plus 712. Okay, second plus 712. And then it'll automatically reset you to radians. Anybody need to calculate it? All right, go ahead once you've done that and type this guy in. Put it in your y equals. Okay, second plus 712, type it in. You don't have an X or a T, but just use an X button instead. Okay. Once you have it typed in, I want you to adjust your window. Okay, so in the question, it says that I'm only using my model from 0 to 4 seconds. So I'm going to adjust my window, which is the button right here, so that my X min is 0 and my max is 4. Okay, I don't want to see more graph than that. It's just extra stuff to kind of ignore. So X min 0, X max 4, go ahead and hit graph. Okay, once you've done that, I want you to give yourself a little sketch of that on your paper. So it goes up, down, up. Okay, this is V of t, which means that it's a velocity graph. First thing I want to know is when the particle changes direction. That would be the places where my graph passes through the x-axis. Do you remember how to find them? Okay, we do want second trace, but before that, you have to put y2 in as 0. Do you remember doing that? So go back to your y equals, and we're going to draw in a second line at 0, and then find where they intersect. So put 0 in as your y2, and then it's second trace, intersect is option 5. And then remember, you're going to push first curve enter, second curve enter, And then by the guess, you want to get close to the intersection that you want. So I'm going to come over to this one on the left first, and then I'll find the other one second. So your first intersection should be t equals 1.5708. Just rounding to that fourth decimal. Okay, find this one. So second trace, option 5 for intersect. Enter on first curve, second curve, but then for guess, you want to get kind of close to this spot. Okay, what number are we getting for that when you have it? 3.1415? Oh, 16, okay. Good. So then those would be the two places where the particle changes direction. So I'm going to put t equals 1.5708, 3.1416, because velocity changes. Now, if you wanted to put, because velocity passes through the, I have no idea. Sorry. You may ask. Okay. Because v of t changes sign. You could also say because v of t passes through the x-axis. That's fine if you like that. Okay, part B. When would my particle be traveling to the right? When it's above the x-axis, which would be here to here and here to here. So write those intervals down. That would be 0 to 1.5708. Union 3.1416 till infinity. So when? My interval ends at 4. Okay, then it says explain your reasoning because v of t is greater than 0, which we know just means my graph is above the x-axis. Okay, next question. I want the particle's acceleration at 2. What is acceleration on the velocity graph? Do you remember? Slope, and we learned how to find the slope, but you might have forgotten. So in your calculator, put acceleration, this is the slope or derivative. Okay, you're going to hit second quit and go into your regular calculator screen. The derivative is math 8. So math, go down to option 8. And it says n deriv for derivative. Then you're going to do ddx. And rather than you retyping the whole equation that you already have typed in, you're going to alpha trace y1. And I want the derivative at 2. Okay, you should get negative 19. Anybody need that again? Okay. So write it down. The acceleration at 2 is negative 19.411. Or 4 will do 09. Okay, then it says, is velocity increasing or decreasing? Well, if your acceleration is negative, what is velocity doing? Decreasing is correct. So I'm going to put velocity decreasing because acceleration negative. Okay, not a very good grammatically correct sentence, but you get the idea. Velocity is decreasing when your acceleration is negative. Now, the next part asks about speed. What am I checking for speed at 2? Acceleration and what? Very good. This is going to be check velocity and acceleration. Now, I already have acceleration. Remember, it was negative 19, but now I need velocity. This is a velocity graph. What feature will velocity be on the velocity graph? Yeah, I don't actually. Is she here, Aaliyah? I think she's not here today. Oh. Sorry. Okay, so velocity at 2 is going to be where the thing is on the graph, which we're going to just say it's the y value. Okay, so let me remind you how to find that in your calculator. Okay, if you want the velocity at 2, you're going to alpha trace y1 at 2. And that's gonna give you the y value. Now, if you look in the table, as long as you're looking for a whole number, it's gonna be there. But what if you wanted 1.5 seconds? Then your table's not gonna have that, so you need to know this way as well. So velocity is gonna be the y value, which is negative 8.7975. Okay, that was the y value. This was the slope. And my velocity also came out negative. What does that tell me about speed? Speed increasing because same sign, right? For V of t and A of t. Okay, so if my acceleration is negative, my velocity is negative, that tells me overall speed is increasing. Okay, all of that you've done before. Now we're getting to almost the new stuff. What about at 3? Take the slope at 3. Okay, if I want the velocity at 3, I'm calculating the y value. Acceleration at 3, I'm calculating the slope. So alpha trace y1 at 3 is negative 4.79, but math 8 at 3 is 31. Overall, what will my speed be doing? Decreasing because the signs are opposite. So I'm going to put here, this is negative 4.7941. This is 31.410. And then we'll put speed decreasing. Okay, if you want to go back and put the explanation, you can. Okay, now let's get into the new stuff. You want an integral expression for displacement from 0 to 4 seconds. So I want you to write the integral symbol from 0 to 4 on velocity. And then we're going to do it in the calculator using math 9. So math 8 is the derivative. Math 9 is the integral. So go ahead and push it. Okay, it's math 9. It says FNINT, that's function integrate. We're going 0 to 4. We're using alpha trace y1 as our function. And then you're putting an x in the last box. Okay, and we got 3.1249. Okay, now remember, displacement tells you how far the particle moved from its initial position. So come down here to this part. If I want the final position at 4, then remember, I need to take the initial position and then add the displacement. So look back in your question. They have to tell you position in the question. Remember, a velocity graph can't give you that. So go back and read. It says at time 0, what does it say the particle's position is on this question? What's the particle's position? -1 plus, what was the displacement we just got? 3.1249. And if you add those together, that's going to give me the final position at 4 seconds. It started at -1. It moved 3.1 units to the right. Then its final position would be 2.1249. But remember, you have to add how far it moved to where it started. Okay, then last question is distance traveled. What do I need to adjust on my integral so that everything counts as positive? Absolute value bars, very good. So you're still going to integrate V of t, but your V of t for distance has to go into absolute value bars. Let me show you how to do that on the calculator. Okay, hit math 9 to open your integral. You're going to still put the 0 and the 4 in the same spot. Okay, and then in this box, don't put the y1 yet. You need to open the absolute value bars first. So you're going to do alpha window, and do you see the ABS? Okay, that's absolute value. So alpha window, open up the bars, and then alpha trace, put your y1 inside them. Okay, and then dx. So the total distance traveled by the particle is actually something. Yeah, it just takes forever because it's having to recalculate over. 30.3226. Now, you might be asking yourself, how are these numbers so different? Go back to your graph for me. And I want you to think about this in terms of area. When I do my integral, all of this area on top and all of this area on bottom is essentially canceling out, except for 3 units left over. But if you don't let the pluses and the minuses get in the way, and you add all those areas up, you would get this 30. Okay, last place I want to show you how to take an integral is second trace in here. Do you see the one that looks like an integral? Number 7. And then you would say, I want to integrate from, let's say my lower limit, I'm going to put 0, enter. And then my upper limit, I'm going to put 4, enter. And then it'll even shade it in for you, nice and pretty, so that you can see all the area that it's calculating for you as it takes forever. Okay, and then you can see your integral still came out to the 3.1248, but that way you can kind of more visually see that your areas kind of crossing each other out. Okay? All right, so get out your computers. We're going to do one question together with the calculator stuff, and then we're done. Yes. Michelle, you gotta go back. Oh. We're going to do the very last one on your homework together. All right, once you have your homework question up, I'm on the very last one. Okay, type your equation into y equals. Okay, that's going to be your first step. So very last question, it's only 4 problems, none of them are sets. And then type your equation into your y equals. The equation you're typing in is a velocity. So if I want to find velocity, that's the y value, right? So once you've typed it in, go back to your home screen and find the y value at 4. So once you've typed it in, you're going to find the y value at 4. Okay, you should be able to do that. That's your answer. If you need help, ask me. Okay, you're going to type that answer into the velocity box because it's a velocity equation and you found the y value. You're going to type into your y equals. Okay, do alpha trace. And then just push that around. And then you'll have to open your own parentheses to put the 4 in. Okay? And then you don't need to be in here. Just do alpha trace. Y1, parentheses 4. Yep. There you go. Good. Okay, so let's type it in for your V. It says you're rounding to the thousandths place, so that'd be 3 decimals. So 6.054. Next, I want acceleration. What is acceleration if I have the velocity equation? Slope or derivative. So push math 8. Math 8. D dx, alpha trace y1. I want the derivative at 4. Okay, look at my calculator. You should get that. 2.029 is going to go to 030. Okay, we need help. Good. Okay. The last one we need to find is position. You have velocity. To get back to position, you're going to have to do an integral. But first, I want you to type in the starting position. So read your question. At time 0, what is the starting position? -2. So put a -2 in here plus. And now we're going to add the displacement to that. So you're going to do math 9 from 0 to 4 on your alpha trace y1 dx. So this is the starting position plus how far it moved. That's going to give you the final position, okay, which is going to be your answer for x of 4. So 9.685. So velocity is the y value, acceleration is the derivative, position is the antiderivative, but you have to add it to the starting position. Okay, from there, let's answer these bottom 4 questions. My velocity is 6. Which direction is my particle moving? Okay, click to the right. Because my velocity is greater than 0. Okay, my velocity is a positive number. That tells me my particle is traveling to the right. Okay, click your drop-down menu here. I want to know if my velocity is increasing or decreasing. Acceleration tells you that. What type of number was acceleration? Negative. Then that means that my velocity is decreasing because my acceleration came out to be a number less than 0. The next question is about speed. What has to match for speed? Velocity and acceleration, do they match? No, one's positive, one's negative. So we would say the speed of the particle is decreasing because v of t and a of t are opposite signs. Okay, and then the last one is towards or away from the origin. We didn't put that in the notes today, but we've done it a million times. My position is positive. Am I on the right or the left side? I'm on the right, and which way am I traveling? Oh, what type of number is velocity? Positive means I'm traveling to the right. So I'm on the right already, and I'm going to the right. Am I going towards or away? Away. Okay, because position and velocity are the same sign. I'm on the right, I'm traveling to the right. That means I'm going away. Okay? All right, you have 30 minutes. Ask me if you need help, especially with the calculator stuff. Your next test, a lot of times the calculator stuff, when you have a calculator, you could have done it in your head if you were really good at math. Okay, for this next test, if you can't do this stuff, you're going to be cooked. Okay, so ask if you need help, but you got to know how to do that stuff. Lamek, and she's not here today. Lamek, are you ready to go save a life? Probably not. Yeah, probably so. Yeah, don't pass out.